So here's going to be an electrostatics introduction. So we're going to look at the atomic structure of atoms and where charges come from, and this is consistent with the follow along. So the follow along is going to be a handout, which can be found on the web page. So electrostatics in the atom, an introduction. Knowing the structure of an atom is important to understanding static electricity. Atoms are made of 3 subatomic particles. However, only one of these particles is free to move around from object to object. By exploring the structure of an atom, you should be able to explain how objects become charged by friction, and therefore generate static electricity. So here's an atomic structure of a helium atom. It's number 2, has an atomic mass of 4. That tells me it has 2 protons in its nucleus and 2 neutrons. It also has 2 electrons that are orbiting in its first shell here in the space surrounding it. So the 3 subatomic particles of which it's made of are protons with positive charge, neutrons have no charge or a neutral charge, and electrons have a negative charge. So the basics are right there. The mass of an atom depends on protons and neutrons. You're really looking at the nucleus. So the protons and nucleus are the primary constituents of the total mass of an atom. The more protons and neutrons, the greater the mass. The size of an atom depends on the electron cloud, right? The surrounding space. The strong nuclear force holds the protons and neutrons together in the nucleus itself, and that's what this gorilla here is depicting. So the electromagnetic force binds the electrons to the nucleus. We're simply looking at positive and negative charge, right? The positively charged protons found in the nucleus and the negatively charged electrons, that's your electrostatic or your electromagnetic force. So you know what they say, opposites attract. That's simply referring to the pluses, protons, minuses, electrons. So therefore the only particle that is free to move from atom to atom is the electron. But there are rules to electrons as well. So we're going to talk in terms of valence electrons and energy levels. So an energy level is a region in the electron cloud with a specific electron energy. The first, or the lowest energy level, holds up to 2 electrons and is closest to the nucleus. The second and third energy levels hold up to 8 electrons. So you can go ahead and plug in 2, 8, 8, and then the fourth level holds 18. So valence electrons are the electrons in the highest energy level. Whatever the outermost level is going to be the highest energy level, what we're going to call the valence electron shell. So atoms can only exchange electrons from the highest energy level, right? The valence shell. So let's put it all together and look at why a balloon sticks to a wall, even though the wall is neutrally charged. It's called polarization, sometimes referred to as charge polarization. So why does a charged balloon, stick to an electrically neutral wall? Well, here it goes. In order to answer this question, we have to look at it in steps. When we rub a balloon on our shirt or our clothes or our hair, we transfer electrons from the shirt, clothes, or hair onto the balloon. So it gains a net charge. The balloon has a net negative charge. It has a surplus or excess of electrons. The balloon gained exactly the number of electrons that the shirt or the clothes or the hair lost. This is explained by the conservation of charge. They're not created. They come from something pre-existing. They're a part of the clothes themselves. So placing the balloon next to the neutrally charged wall leads to some atomic charge relocation, right? The electrons. The surplus electrons in the balloon repel the electrons in the atoms of the wall, right? We know negative charges are going to repel negative charges. The relocation of electrons leads to a slightly and temporarily positive surface of the wall. Notice, the wall didn't move. The electrons were repelled. Notice we have a positive charge. The nucleus didn't change. Remember, the nucleus houses the protons and neutrons, in this case a positive charge. So the negatively charged balloon is attracted to the positively charged surface. So it stays electrostatically in place. And this is a force that's generated because the balloon has a negative charge, repels the electrons, is attracted to the slightly temporarily positive surface. So why doesn't the charged balloon stick to a metal doorknob? Well, the metal doorknob has free moving electrons. It is a good conductor, right? It's a metal. So the surplus or the excess of electrons from the balloon jump from the balloon to the metallic conductor, right? The doorknob, thus neutralizing its charge. It's the same effect here if we touched it with a charged hand. So after touching the doorknob, the balloon is grounded and has no net charge. And that's really what grounding is. It's taking a net charge of an object and kind of decharging it. It's taking away that net or excess charge. So much like that of when you get an electric or static shock, by transferring electrons from yourself to the door, the balloon would have a similar effect.